Alright, in this video we are going to practice adding rational expressions such as this one. I will also show you how to solve a system of rational equations such as this one, and I will show you how to solve a rational inequality like this one. The first thing you should do is see if there's a common factor that you can pull out. And in this case, there's a common factor of 3. So if I were to rewrite this, I would have x plus 1 over, so the GCF is 3. So that's going to leave 3x minus 7. All right, and I'm going to space this out a little bit, so I've got 2/3. Now, you see I left all this space over here. That's because I know when I'm adding fractions, I need like denominators. Because I pulled out the GCF, I see there's already a 3. So what I need now is a 3x minus 7. And I'm going to have to put that in the top and bottom, so I'm not really changing anything. Now, I'm not going to cancel these out. And I certainly will not cancel out what I just put in. Instead, because I have like denominators, I'm going to wind up putting these together. So, it's going to be like this. I'm going to keep my like denominator of 3 times 3x minus 7. And now here I've got x plus 1 sitting there. Now over here I've got a little distributive property happening. So that's going to be plus, that's going to be plus 6x minus 14. Okay, so combining like terms, I've got x and 6x, so that makes 7x. Then 1 and negative 14 makes negative 13. All right, and that's going to be over 3x minus 7. All right, you should always look and see if there's another GCF that you can do anything with. I don't see anything else, so this can be our final answer. Okay, now let's go ahead and solve this system of rational functions. So the first thing you want to do when you're solving a system is to set them equal to each other. But don't forget, when you see y equals this and y equals that, we're going to not only find x, but we're going to find y. So when you see y, don't forget that you need to find y as well. So if I set these equal to each other, then I've got negative 25 over, and you know what, I might as well go ahead and factor this. So x squared, so I've got x times x, 10 is 2 times 5, negative 2 and a positive 5 will give me the 3, and a negative times a positive is a negative, so there we factored it. And so continuing on, I've got 5 over x minus 2. Whoops, I moved it. Alright, I might as well put the x minus 2 in parentheses, and I'm going to leave some space because I know what's coming. And I'm going to set this equal to x over x plus 5. Okay, now we need like denominators. There are many ways to solve these problems, but the method I'm going to do now is I'm going to make like denominators and then I'm going to cancel them all out. So this has a little bit of everything. It's got an x minus 2 and an x plus 5. So I'm going to make all the rest of the denominators like this one. So all this fraction needs is the x plus 5. Got to do it in the top and the bottom. Now this fraction, it needs the x minus 2. So I'll do x minus 2 in the top and the bottom. Okay, once the denominators are all the same, you can cancel them out. So I'm going to cancel out all the denominators. Alright, so that leaves me with negative 25 plus Okay, I'm going to do the distributive property here, so that's going to be 5x plus 25 equals, and right here I'm going to have x squared minus 2x. Alright, so I see that I've got x squared and x, so I'm going to get 0 on one side. Now, if I combine these like terms, the negative 25 and the positive 25, they cancel each other out anyway. So I'm just going to subtract 5x from both sides. So that's going to give me 0 is equal to x squared minus 7x. So that's going to give me 0 is equal to, and so I can factor this by pulling out a common factor of x. So that'd be like x and x minus 7. So setting these equal to 0, alright, it's like I'm splitting these apart. So I've got x equals 0, and over here I'm going to get x equals 7. So these are my two x values. Alright, but I need to find the y values that go with them. In other words, I've got 0 comma something, and I've got 7 comma something. For my final answer, I need those y values. So what you do is, we're going to use our TI-30 XS multiview. Take one of the two original problems and put it in your table feature of your calculator. I'm going to use this one because it's much simpler. Alright, so we hit the table button, and let's type in x over x plus 5. Okay, I like to be in ask mode when I do this. Alright, so now I can type in any x value and get the y value that goes with it. So I have 0 and 7. So I'm going to type in 0, and I'm going to type in 7. So 0 comma 0 and 7 twelfths. So 0 comma 0 and 7 is 7 twelfths. Okay, and that is how you do that. Okay, for the last problem on this video, we're going to solve this inequality. Now, as soon as you see it's an inequality, you'll remember that drawing a number line is going to be the way to go. We're going to draw a number line to help us out. But what to put on our number line? Well, first thing you should do is make this an equation and solve it. So you know what, I'll bring back the number line in a minute. I might need some space. So let's make this into an equation and solve it. And that solution is going to be one of the things that will go on my number line. So let's see, I've got 5 over 3x, 3 over 4x equals 5 over 6. So when I'm solving an equation, there are many ways to go about this, but I like the technique of making all the denominators the same and then canceling them out. So I'm looking at 3, 4, and 6, and I'm wondering to myself, what number can these all be turned into by multiplication? Well, 3 times 4 is 12. 2 times 6 is 12. So I see a lot of 12 going on here. So I'm going to make these all into 12x because I see I have an x. So I can make this into 12x by multiplying it by 4. Alright, you have to do the same things to the numerator and denominator, but I've got a 12x now. If I multiply this one by 3, that makes this 12x. Got to go top and bottom. This I would have to multiply by 2 and x to make 12x. So I'm going to multiply by 2 and x in the numerator. So now I have 12x, 12x, 12x in the denominator. Once the denominators are the same, you can cancel them out. Okay, so now I have 20 minus 9 is equal to 10x. All right, wow, that's a simple little equation. So 20 minus 9 is going to be 11. So that's going to be 11 equals 10x. And to get x by itself, I will divide both sides by 10. All right, so x is equal to 11 over 10. So this is one of the things that is going to go on the number line. Okay, it would help to have this as a decimal just to help me place it on the number line. 11 over 10 is very close to 1. Let me check it out. 11 divided by 10, that's 1.1. I knew that was silly. Okay, obviously it's 1.1. You move the decimal over. Silly me. So that's one thing that's going to go on the number line. Okay, now what's the other thing? Any excluded values. So there's only one excluded value here. Looking at the denominators, I see the 3x and the 4x. This tells me that x cannot equal 0. I mean, if you want, you can think of it as setting 3x is equal to 0 and solving. All right, 0 divided by 3 is 0, so x cannot equal 0. So there it is. Those are the two things. X cannot equal 0. X does equal 1.1. These are the two things that I will put on the number line. All right, well now it's time for that number line. So here we go. All right, so I've got 0 and 1.1. So here is 0. Okay, and here is 1.1, also known as 11/10. Okay, so this creates three different zones that we need to test out. So in this zone, we could test the value, let's say -1. All right, now looking back, see this is a greater than sign. Now ultimately, we're going to use our calculator to help us test these zones. But to put this in our calculator, we need 0 on one side. So what I would do is I would move this over by subtracting 5/6 from both sides. All right, basically this is going to move over and change signs. So the thing that's going to go in my calculator is this. I will have 5 over 3x minus 3 over 4x, and then now I will have minus 5/6, and I have is greater than 0. So this is what I'm going to wind up putting in my calculator. All right, but I need to see, is it greater than 0? Where is it greater than 0? That's what we want. So I'm going to be testing to see, is it greater than 0 here? Now in here, I need something between 0 and 1.1. So I could just use the number 1. All right, because 1 is less than 1.1. So I could see, is this greater than 0? I could also use a decimal like 0.5 or something like that. And over here, I just need something that's bigger than 1.1. So something like 2, for example. Okay, Now, as far as the border points, the endpoints, I'm going to put some circles there, and they will either be open or closed. Now, excluded values will always be open circles, so this will definitely be an open circle. Now, the solution, all right, the 1.1, the 11 over 10, will either be open or closed depending on this symbol. If it's or equal to, then it will be a closed circle. But since it's just greater than, then it will be an open circle. So I'll have an open circle right here to show that right at these points, this is where it would be equal to 1.1. And but we need it to be greater than. So we'll leave it an open circle. So now let's test the values in between. So like I said, I'm going to put this into my calculator in the table feature. So hit table, and I've got 5 over 3x, so 5 over 3x. And then I've got minus 3 over 4x, so 3 over 4x. And then minus 5 over 6. So 5 over 6. Enter. Now I like to do this in ask mode. So I'll go over to ask mode and hit enter a couple of times. So now it's waiting for me to put in any x value I want, and it will tell me the value of the function, you know, the y value that goes with it. So, like I said, I'm going to test out these three values, -1, 1, and 2. So here I go, -1, 1, and 2. Okay? Now, I want to know where is it greater than 0. In fact, let's just write this down. So we have -7/4. So the question is -7/4 greater than 0? No, it is not. Okay, what about at 1? We had 1/12. So the question is 1/12 greater than 0? Why, yes it is. That's a positive number, so it is greater than 0. At 2, I have -3/8. So that means is -3/8 greater than 0? No, that's a negative number. It is not greater than 0. So the yes tells me where the solutions are. All right, that means the value of 1 is a solution to the inequality. That means all the points in between here will be solutions to the inequality. So I'll show that by drawing this segment. If these had been yeses out here, I would have drawn the arrows going outward. So this is a graph of my solution set, and of course I would like to write this in interval notation. So it goes from 0 to 11/10. So I'll put 0 and then comma and 11/10. Alright, now because this is an open circle, I'm going to use a parenthesis. Same over here. If this had been a closed circle, I would have done a square bracket. Alright, so it looks like a point. It looks like an ordered pair, but it is not. This is an interval saying from 0 to 11/10. That's where we will find the solutions to this inequality. Alright, so that's how you solve a rational inequality.